Hello everyone, welcome to day 2 of our topic about counting number of occurrences of outcome. So for our lesson objectives, we have analyzed the probability problem to find the number of occurrences of outcome and find the number of occurrences of outcome in an experiment using the FPC or fundamental principle of counting. So let's focus on the first objective. So let's have here our example exercises wherein a bag company manufactures 2 styles, 2 colors, and 2 sizes. How many bags are available? Okay, so you are going to analyze the given problem. So it is said that we have 2 styles. So we have the sling bag and the handbag. We have the 3 colors. We have black, white, and gray. And 2 sizes, we have the small and large. And for us to solve this, you are going to take note of the number of styles, colors, and sizes. And you are going to multiply them because we are going to use the FBC or fundamental principle of counting instead of using the tree diagram, listing method, or systematic listing and table form. So instead of using those methods which are long enough, so we have here the short method, the FPC. So we have 2 styles, 3 colors, and 2 sizes. So we are going to multiply that for us to have the combinations of bag or the styles, colors, and size of bags that are available. So we have here 2 times 3 times 2 is 12. Okay, question? So let's now have the second one. How many dinners can be served in a restaurant consisting of soup, drink, main course, and dessert if a customer can choose from 2 soups, 5 drinks, 4 main course, and 2 desserts? Okay? So what are you going to do? That's correct. We have to identify, the number of meal that you can choose from. Okay? So what are you going to do? Okay, so you are going to, you are going to multiply the number of soups by the number of drinks, by the number of main course, and 2 desserts. Okay, so we have here 2 times 5 times 4 times 2 is equal to what? Okay, so that's correct. So we have 80 combinations. Okay, so any question? Okay, next, let's apply. So how many 2-digit numbers can be formed from the digit 1, 2, 3, 4, and 5 if the digits are even numbers? Okay? So we all know that even numbers are those numbers ending in 0, 2, 4, 6, and 8. So as you have seen on our given digits, so we have only, 2 even numbers. Okay? And since we are going to make 2-digit numbers, so we have the tens digit and the ones digit. Okay? So you have, so we have here 2 ones and 5 tens. Okay, so why do we have 2 ones? Because it is said that you are going to find for the even number, and you will just have the ending number in 2 and 4. So that's why our ones will be 2. And we have here 5 tens because we have here 5 digits given. 1, 2, 3, 4, and 5. So 5 times 2 is equal to, okay, correct, 10 number. So this is the number of even numbers formed, 10. Okay? Next. So we can also have here the listing method. So we have here, okay, so as you have seen, I have scrolled down the possible answers using the listing method. So 12, 14, 22, 24, 32, 34, 42, 44, 52, and 54. So still we have 10 combinations. Okay, next example. How many 2-digit numbers can be formed from the digit 1, 2, 3, 4, and 5 if there is no repetition. Okay? So again, we are going to have tens and the ones digit. So since we have here the condition that there should be no repetition, so you will have here 5 tens and 4 ones. Okay? Because you will have no repetition. So 5 times 4 is 20. And for us to have the proof, so we have here the digits 1, 2, 3, 4, and 5 as our tens. And then our ones will be given as I have scrolled down. And again, take note that there should be no repetition of the variable. So there should be no 22, there should be no 11 because those digits 1 and 2 are repeated. Of course, there should be no 33, no 44, and no 55. Okay? So, as you have seen by listing method, so we have here the proof. Okay? So, how many combinations or how many two-digit numbers can we have? So, we have here 20 combinations or 20 numbers. Okay? Question? Okay, next. Let's have problem 5. How many two-digit numbers can be formed from the digit 1, 2, 3, 4, and 5 if repetition is allowed? Okay, so again, take note, repetition is allowed. So again, we have here the tens and the ones digit, and then the numbers formed with repetition will be obtained. Okay, so we will have here 5 tens, and since we have here the repetition is allowed, so you will still have 5 ones. So 5 times 5 is equal to, yes, 25. So the proof, so we have here the tens digit will be 1, 2, 3, 4, and 5. And then from the tens 1, so we have here the ones 1, 2, 3, 4, and 5. And also with 2, followed by 3 with 1, 2, 3, 4, and 5. Followed by 4 with 1, 2, 3, 4, and 5. And 5 with 1, 2, 3, 4, and 5. And the numbers that you will form will be with repetition. So 11, 12, 13, 14, 15, 21, 22, 23, 24, 25. Then 31, 32, 33, 34, 35. Then we have here 41, 42, 43, 44, and 45. And lastly, we have 51, 52, 53, 54, and 55. If you are going to count all of them, so we have here 25 combinations or 25 numbers. Next, so let's solve this problem. Using digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many 3-digit numbers? So this time we have to find for the 3-digit numbers. Can be formed without repetition of digits. Okay, so since we have to form 3-digit numbers, so we have to include the hundreds, followed by tens, then ones. Then, we can find for the number of combinations. Okay? So, we have here, without repetition, so we have the hundreds digit will be 9. Since without repetition, so the tens digit will be 8, and the ones digit will be 7. So, 9 times 8 times 7 is equal to, correct, 504. Okay, question. Next, this time, using the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, how many 3-digit numbers can be formed with repetition of digits? So this time, we have the repetition of digits. So still, we have the 3 digits, so the hundreds, the tens, and the ones. And then we have 9 for the hundreds. Then since with the repetition, so tens digit will also be 9. And also with the ones digit. And then 9 times 9 times 9 is equal to, correct, 729. 3-digit numbers or combinations can be formed out of these digits, 1 to 9. Okay? Question? Okay, next. Using the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, how many 3-digit odd numbers can be formed without repetition of digits. Okay? So still we are going to have the 3 digits on the hundreds, the tens, and the ones. But this time, take note that you are going to have the odd numbers. So from our given digits 1 to 9, the odd numbers are 1, 3, 5, 7, and 9. So we have 5 ones there. Okay? Because we are given 5 odd numbers. So this should end with these numbers. And then we are going to have the hundreds digit. So since we have 9 digits, so we have here 9. And then the tens digit will be, okay, 9. Because with repetition. So it means you can repeat the digit. Okay? So 9 times 9 times 5 is equal to, correct, 405. Okay? Next, using digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many 3-digit odd numbers, still the odd numbers, can be formed but this time without repetition of digits? So what will you do? Okay, so still we have the hundreds, tens, and ones, and then again odd numbers will be 1, 3, 5, 7, and 9. So still our ones digit here will be 5. Followed by the hundreds digit, which is 8. Okay? Because you should have no repetition. So without repetition. So, and then the tens digit will be 7. Okay? So this becomes 8 because since we already have here 1 for 1, so that's why we just have here 8 for no repetition of a digit. So we have here 8 times 7 times 5 is equal to, correct, 280. Okay, question in this problem? Okay, next. How about if we have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many 3-digit numbers can be formed with repetition of digits? Okay, so again, hundreds, tens, and 1. So we have the hundreds digit will be 9. The tens or the ones digit will be 10 because we have here given 0. And then the tens digit will be also 10. Okay? And then 9 times 10 times 10 is equal to, correct, 900. Okay? Any question? So let's have this one. In how many ways can 7 students be arranged in a row if there are only 3 seats? What will you do here? Okay, so we have here the seat 1, seat 2, and seat 3. So, we are going to have the seat 1 will be 7. Times seat 2 will be, or the seat 3 will be 5. And seat 2 will be 6. Okay? Or simply, of course, the student seated in seat 1 is different in seat 2. And the student in seat 2 is different in seat 3. So that's why we have here 7, 6, 5. So 7 times 6 times 5 is equal to 210. Okay, did you get it? Okay, so that's all for this day. Thank you and God bless.